Hi, today we're going to present forest cover type prediction. We are in group number 5 and our group members are Rayna, Yuan, and Zheyue. So for today's presentation, we're going to introduce in 4 steps, which are introduction, data processing, model selection, and conclusion. First of all, let me introduce our project. Global forest cover is crucial for soil health, water cycle, climate, and air quality. Thus, forest cover is closely related to our life. And the cover type is the predominant kind of tree cover. And this study is included 4 wilderness areas which are located in the Roosevelt National Forest of Northern Colorado. To describe the dataset, our dataset, it comes from the Kaggle competition. And for our dataset, we have training dataset and a test dataset. Besides, it's also including 10 different features and 1 target variable, which is what we're going to predict. Furthermore, wilderness area has 4 different types, and the soil types totally has 40 types. Since it has too many different types, so here we just list 5 of them. The photo here shows that we have 7 different kind of current type, and that is what we're going to predict in our model.
Let's talk about the data processing. We prepare the datasets by following the pipeline for the classification. First, we load the training and the testing file. The training sets have the 50,000 observations, which contains both future and the target in total 56 columns. And the testing set has about 565,000, which contains only the futures. Then we divide the training data into the 80% for training and the 20% for validation. We were not going to use the testing sets for modeling. Then we handle the uncommon feature in the data. Fortunately, we didn't have any uncommon feature in the data. Then we took the next step to remove the identifier in the data because the identifier has no predict power over the target. Then we continue to handle the daytime variable and the missing data and encode the data. Each dataset contains the 4 binary columns of the wellness errors and the 40 binary column of the soil types. Also, the target of the cover types are integer 1 to 7. Therefore, no category variable need to be encoded. After all above steps done, we split the data to get the future metric and the target vector. Since if we change a model on the data with such different scales, the prediction accuracy would be significantly lower. So we have to standardize or scaling the data. Each dataset has the problem in class imbalance, and we address this problem by setting the class weight hyperparameter as the balance when we fix the model.
Now let's talk about model selection. We explored 8 different models to find the best one for our project. And the pipeline of it is that firstly, we will create a dictionary of classifiers and adjust hyperparameters for each of them using Grid Search CV. We updated the best scores of the parameters and sort results in ascending order. The 8 classifiers are K-neighbors classifier, which implements the K-nearest neighbors vote, and the multi-layers perception classifier, which is a neural network, and the histogram-based gradient boosting classification tree. This estimator is much faster than gradient boosting classifier for big data. And we also experiment with different kind of decision tree classifiers. And the difference is that random forest is a meta estimator that fits a number of decision tree classifiers on various subsamples of the dataset and uses averaging to improve the predictive accuracy and control over fitting. And the extra trees classifier fits a number of extra trees. We also use logistic regression and C-support vector classifications to find the best fit of our data. And the reason we tried out these models is that according to the sklearn classifier comparison documentation, different classifiers has different decision boundaries to separate the data. From the graph, we can see that the data are linearly separated by linear SVM, neural nets, naive Bayes, and QDA. And the data are divided in curved region and nearest neighbors, and circular region in RBF, SVM, and Gaussian process. In squared region in decision trees and AdaBoost. So from each type, we chose some classifier to experiment with and to fine-tune hyperparameters for decision tree, random forest, and hist gradient boosting classifier. We adjusted the minimum number of sample required to split an internal node and required to be a leaf node. And for logistic regression, we fine-tune the tolerance for stopping criteria and the inverse of regularization strings. As for the multi-layer perception classifier, we adjust the regularization term parameters and the initial learning rates used, which controls the step size in updating the weights. And for the SVC, we explored the one versus rest and one versus one decision function shapes. And for the KNN, we controlled the number of neighbors to used by the default for k-neighbors queries, and the algorithm used to compute the nearest neighbors. And last, for the extra tree classifier, we adjust the number of trees in the forest and the maximum depth of the tree. As a result, the extra tree classifier performs best for our project, which is 3 per thousand higher than the hist gradient boost classifier, 0.01 higher than random forest classifier. Also, the SVC and logistic regression didn't work well for our project.
Alright, so let's move on best model analysis. Based on our best model, here are 4 important variables which are elevation, wilderness area in type 4, fire point, and the roadways. So from the elevation, which is measured elevation in meters, the importance is which is 0.184323, and the second one is wilderness area in type 4, and the importance is which is 0.101644. And for 5 point, the importance is this one, and the roadways importance is this number. Now, let's move on conclusion part. Since based on the previous step, we already pick out the best model, which are extra tree classifier, as this one has the best score. What's more, we found that elevation in meters, wilderness area type, the horizontal distance to nearest roadway, fire point, and surface water are also the most important feature in our model. So, below are our work findings, and thank you for all of you to participate.